of time, we start with year. Year, so 1 year is how much? If this is our sun, Earth here, so the time taken for Earth to complete one revolution, defined as the time in which the Earth completes one revolution around the sun. That time taken is called as 1 year. This is 1 year, and its value we have taken how much? Approximate value we have taken 655 days. 1 year of 655 days. But in reality, it is how much? Or 366 days leap year we used to take. Okay, 365 days. Okay, this we have taken. In reality, how much time it takes? 365.2422 days. That is 1/4 of the day extra it takes. Okay. Next, we discuss leap year. So see here, after every 4 years, this 0.244, it will become around a 1 day. So leap year, it consists of 366 days. In leap year, in month of Feb, we add one more day. In Feb, we add one more day and it becomes 29 days. This you understood? In a year, in normal year, we take 365 days. In leap year, we take 366 days. That is, in Feb month, instead of 28 days, we are taking 29 days. Okay, this is clear. Now, how to find the leap year? So the years which are divisible, perfectly divisible by 4.
Or
If they are divisible by 4, then those years are called as leap years. Whereas there is one exception. There is one exception, that is century years. Century years means 1800, 1900, 2000, 2100. So here we have to apply one more condition, that is they are divisible by 4. Okay, these years must be divisible by 400. If these years they are divisible by 400 century years, then that year is leap year. For example, 1800, it is divisible by 4, but not divisible by 400. So for century years, we have to check one more condition. That is, they has to be divisible by 4. They have to be divisible by 4. 1800 not divisible by 4, not a leap year. 1900 not a leap year. Whereas 2000 it's a leap year. 2100 not a leap year. But 2400 it will be a leap year. It will be a leap year. It is divisible by 400. This is clear. This you must understand. So any year that is divisible by 4 is leap year. But the century years, we have to check whether they are divisible by 400 as well or not. If they are divisible by 400, then that particular century year is a leap year. Okay. Next bigger unit is decade. Decade means 10 years. One decade equal to 10 years. And century, one century equal to 100 years. They are bigger units. More bigger units, millennium. 1 millennium is how much? 1000 years. So one decade, 10 years. And we can convert it into seconds. 1 century, 100 years. We can convert as well into seconds. And 1 millennium, how much? 1000 years. Like 2000 was a millennium, second millennium. Okay, we can convert it into seconds. Okay, so these all we have discussed units. Now, so till now what we have discussed? 3 fundamental quantities we discussed. Which are the 3 fundamental quantities? First was the length, then mass, and then time. And their respective SI unit we have defined. Mass, first length we have discussed. Length, its SI unit was meter. We defined it. Other units we derived in its terms. That is metric units and non-metric units. Okay, in non-metric unit parsec we have to discuss. Then we have mass. Mass, kg unit. Kg was the SI unit and we defined kg. Okay, time we defined second. And other units we derived in terms of second. Okay. Now one unit we have left in length, that was non-metric unit, parsec. It is made up of 2 words, that is parallax Second is second. It is angle. Parallax, see here. What is parallax? See here. You are having two eyes. There is distance between the two eyes. When you see the finger, two fingers you place it. Now close your one eye. Okay, when you close your left eye, you see what? This finger, near finger is on this side. But when you close the right side, you see this finger is on that side of this finger. So this near finger, it has shifted more as compared to the finger that is far away. More shift in this finger. There is parallax. This is called as parallax. Using this property, we will derive parsec. So see here, we are having a sun, we are having, okay, and earth we have. So earth is revolving in this orbit, okay. Okay. Now, once it is closest to the sun, one farthest to the sun. Okay. But we have taken the mean distance from the sun. That is, if we are taking the mean distance from the sun, that is 1 AAU. Mean distance we have taken, and then we can represent it like this. Sun, we can take it here center, and Earth, one's position here. This is 1 astronomical unit. And on the other side, 1 astronomical unit. We are taking mean position. So for example, there is some point, a point we are taking. For example, consider it as a star. Okay. From here, we are seeing once. Okay. Once, when the Earth is on the other side, we are seeing the again the star. Okay. Now it is subtending some angle. It is subtending some angle. These two positions, it is subtending some angle, and from the center we join it to the sun. That will be the center. So this is the major axis, and this is what? Half of the major axis, that is semi-major axis. So this distance is 1 AU. Okay, and this angle, the point is such far from here, such that angle subtended here is 1 second. Angle subtended here is 1 second. Okay, for initially we take this angle as theta. Initially we are taking this angle as theta, some angle theta. This is the distance d. This is the distance d that we have to calculate. Okay. Okay. Now tan theta. Have you okay? Tan theta you haven't read, so studied this in mathematics. So when you study these trigonometry properties, it will be getting more clear. We can discuss this thing after the during the completion of this. When you trigonometry is completed, we can discuss it again. Okay. So tan theta means perpendicular upon base. It's a right angle triangle. So perpendicular upon base. Perpendicular is what? 1 astronomical unit. This distance divided by this distance, d. Okay. Now, since theta is very, very small, since theta is very, very small, so this we can take equivalent to theta. Okay. So we can write theta equal to 1 AU divided by d. Or we can write d equal to 1 AU divided by theta. Okay. Now see here, if we are taking this angle as 1 second, okay, in radians we are taking, okay, first in seconds. If we are taking this angle is 1 second, then this distance will be 1 parsec. This distance will be 1 parsec. You can see the definition as well of parsec. 1 parsec is the distance from where the semi-major axis, this is semi-major axis, subtends an angle of 1 second. The distance where this semi-major axis subtends an angle of 1 second. This is the definition of parsec. How we are deriving? So d equal to 1 AU divided by 1 second. Okay, this d will become 1 parsec because 1 AU is subtends an angle of 1 second at this point. Then the distance is called as 1 parsec. Okay. Now see here. This 1 second we have to convert it into radians. In radians we have to convert, okay? So we all know 180 degree, how many radians? Pi radians. 1 degree, how many radians? Pi upon 180. In 1 degree, how many minutes? 60 minutes. That is, angle we are dividing 1 degree into 60 parts. It will be pi upon 180. So 1 second, 1 minute, so into 1 upon 60. Again, in 1 minute, how many seconds? 60 seconds. So 1 second, again we will divide. Pi upon 180 into 1 divided by 60 into 1 divided by 60. We can write 360. Pi divided by 180 into 1 divided by 3600. Now instead of 1 second, we can write pi divided by 180 into 1 divided by 3600. So 1 parsec in numerical value, if we solve, it comes out to be 3.08. 1 AU we can subtend, we can write in terms of meter. It is how much? 1.496 into 10 raised to the power 11 meter. And when we solve it, it comes out to be 3.08 into 10 raised to the power 16 meter, 1 parsec. Have you understood or you have any doubt? 1 parsec is nothing but is the distance from the point, that is this point, it is how much far? Is the distance from 1 AU, substance in an angle of 1 degree. Is the distance from the semi-major axis of the orbit of the Earth, subtending an angle of 1 second. That is called as 1 parsec. Understood this one? Any doubt?
No, sir.
Okay, so you can
Sir, why do
video.
we took tan theta as theta?
See this theta. Okay, initially we are taking this as distance d, this angle as theta. Okay, so okay, I rub that. Tan theta we have used. Tan theta means perpendicular upon base. This is right angle triangle. This angle opposite to it, this one, and is the base. So tan theta equal to perpendicular 1 AU divided by base is d. Okay, and tan theta, since theta is very, very small, this point is very, very far away. It's very small. 1 second if you are taking, it's a very small angle. 1 degree you are divided into 60 parts, and each minute, each part again into 60 parts. So tan theta is equivalent to theta, 1 AU divided by d. So when theta we are taking 1 second, d will become 1 parsec. So theta, it will be 1 second equal to 1 AU divided by 1 parsec. Or we can say 1 parsec equal to 1 AU divided by 1 second. And then we have just substitute 1 AU equal to 1.496 in 10 raised to the power 11 meters. And 1 second we have converted into radians. This is the way to convert the radians. Each second there are 60, each minute, each degree there are 60 minutes. So divided by 60 will give us 1 minute. 1 second again in each minute there are 60 seconds. So divided by 60 will give us 1 second. And this we have substituted and we have calculated, and it comes out to be 1 parsec. Okay, do one thing, go through the video again. If you don't understand, ask in next class. Okay, parsec.
Okay, sir.
Okay, so go through the whole chapter today and tomorrow. On Monday, if you have class, you can ask the doubts. Okay, so we can start some derived. Now see, we have discussed the units of length, mass, and time. Now see, there are other physical quantities whose units, like we have discussed, fundamental quantities and derived quantities. Okay, so derived quantities, they depend on fundamental quantities. So for example, area is a derived quantity. How we derive area? That is length into breadth, that is meter into meter, so meter square. So area depends on length. meter and meter. Area, so it's a derived unit. It's a derived unit. Similarly, take any density you take. Density, what is the formula for density? Mass upon volume. Okay. Mass is a fundamental quantity. So mass is what? Kg. Whereas volume, it's a derived quantity. Volume, meter into meter into meter. Meter cube. So kg per meter cube. So density is a derived quantity and this is the derived unit. Understood this one? Other derived units, you can go through them. These all are derived unit. Symbols used, you know. Okay. Now we discuss guidelines for writing the units. So what guidelines we must follow while writing the units? So first one, read. So first one, if the symbol for any fundamental quantity, it is named not after the scientist, named not after the scientist, after a scientist we can say. So if the unit is not named after any scientist, if the unit is not named after any scientist, then the symbol will be used, that unit will be written in small letters. That unit will be written in small letter. For example, meter, it is not named after any scientist, so its symbol will be meter, M. So you know it's small letter, small letter. Second, small letter, its unit, its symbol, second. Again, small letter. So any unit which is not named after a scientist, then it will be written in small letters. It will be written in small letters. Okay. Now, if it is named after a scientist, if the full name we are using, then it will be written in small letters. For example, Newton. Newton is the unit of, we have studied it. Newton is the unit of force. N-E-W-T-O-N. So if we are writing full name, then small letters. But if we are using the symbol N, capital N. Pascal is a unit of pressure. So capital P, then A. Okay. So if the symbol for a unit which is not named after a scientist, if the unit is not named after a scientist, we'll use small letters. If unit is named after a scientist, if you are writing full name, then small letters. But the symbols will be having the capital letter. Initial will be the capital letter. Like J for joule, W for watt. Watt is a unit of power. Capital W. Okay. This is clear. If it is not named after a scientist, we'll write small letters always. If it is named after a scientist, the name will be written small letters. But the symbol N, P, A, W, the initial will be written as capital letters. So full name, small letters always. So only we have to remember whenever we are using the symbols N, P, A, if they are named after a scientist, it will be capital, or else it will always be small letters. Okay. Now, for example, compound units. If we are having compound units, for example, we are having two or more units. For example, torque, Newton meter. Force into the distance, perpendicular distance. This is one, we can write it like this, or this is dot product, Newton cross product meter, or just Newton meter. We are having some space between them. These are compound units. We can write them like this. Okay. Newton dot meter, those all. Now, if negative power for compound units, if you have a negative power, like for example, velocity we have, velocity unit is what? meter per second. We can write it as meter s raised to power minus 1. We can represent the quantity in denominator as raised to power minus 1. This way we can write. Understood? Or the unit of power is joule per second. Joule per second. So that we can write it as joule. Joule is named after a scientist, capital J. Second not named after a scientist, we can write it like this or this way. Understood this one? Now, if having any plural, like 10 meters we have. So 10 meters, we are never going to write plurals. Cannot be, for example, 10 meters we have. M-A-T-R-E-S. It cannot be written as 10 ms. This is wrong notation. It will be meter second. Okay, it will be 10 meter only. So in plurals, we don't write as. Okay, 10 meters will be written as 10, only m will use, not ms. Okay. Similarly, 5 kg, 5 kilograms, 5 kg only it will be written. Okay. Now to avoid the powers of 10, we used to have the prefix like deca, deci, mega, giga. So those prefix we can use only once. For example, it is 5. Okay, 5 kilo mega watt. Okay, so this notation is wrong. We cannot use two prefixes. So kilo means 1000, mega means 6. So we have to write it as 10 gigawatt. That means 10 raised to power 9 watt. We cannot write two prefixes. Okay. Next is when prefix is used as a symbol for unit. Symbol for unit, then the new unit, it will be complete. It becomes a new symbol for the unit. For example, we have kilometer. It is kilometer. So when I'm writing kilometer cube, it means this cube is not just for meter. It is for whole. It is for whole. Kilometer, the whole. Okay. So for example, I'm writing 1 kilometer cube. It means 1 kilometer into 1 kilometer into 1 kilometer. That means 1000 meter into 1000 meter into 1000 meter. Understood this one? So there is no no need of putting the brackets. If we write, we have to take the cube of kilometer. It means this kilometer will be the new unit, and if you put 3, it means this cube is for the whole. That is for the whole kilometer, for 1000, 1000, 1000. Understood this one?
Yes, sir.
Okay. So with this, we complete the chapter. Any doubt you have, you can ask. If no, then we can start the numericals. Okay. Exercise first day. All the question answers, try to find out, mark in your book, or if you want to write, you can write some questions from them. It's up to you. But numericals must be there in notebook. Okay. So we'll start with numericals. Okay. So first one, start doing the numericals. The wavelength, page number 10. Okay. Before that, I have to tell you something. Up in page number 5 once. Up in your page number 5. Your book's page number 5. Okay. See here, if you are using a old book, then here the mass of 6.02 into 10 raised to power 23 atoms is written. If you are using an old book, Kapil, please mute yourself. Okay, I have muted. Okay. The mass of 6.0, if you are using an old book, then if you are using the old book, then you have to make the correction. In the new book, it has been corrected. So if you are having a new book, no need of any correction. If you are using old book, then the mass of 6.02 into 10 raised to power 23 is written. Okay. So you can make 26. Of carbon 12 is 12 kg. Okay. If it's old book. Okay. One more correction. If it's old book, then here per gram atom. So here in 1 gram, see here. In 1 gram, number of atoms is how much? 6.02 into 10 raised to power 23. These many atoms. In 1 kg, these will be 6.02 into 10 raised to power 26 atoms. This is Avogadro number. Okay. So in new book, you don't have to make any correction. In new book, you don't have to make any correction. Okay. If you are having old book, then you will make the mass of 6.02 into 10 raised to power 26. Atoms of carbon 12 is 12 kg. Okay. Here. And at last, Avogadro number n equal to 6.02 into 10 raised to power 23 per gram atom. Per gram of atoms. Okay. This is clear. In new book, no need of making correction. That has been corrected. Okay. Now we can start the numericals. First one. The wavelength of the light of a particular color is 5800 angstrom. Express it in nanometer and meter. That you can do. If you are phased out, simply we can do 1 extra unit is 1/10 of nanometer. So we have to divide it by 10. We get into nanometer. Into meter.
Sir, we have to write questions.
No need of writing questions. Don't write any questions. Numericals you do in notebook. Just write the just solve them. Okay? Just solve them. No need of writing questions. You have to solve the numericals in your notebook and the word questions, the questions which is having answers that you can mark in your book. Go through them. I'll be asking you in next lecture. I'll be taking oral test in next lecture. Okay? As well, we'll be doing the numericals in next lecture. Okay, so in this first, second, third, fourth, fifth, sixth, you try doing yourself. Seventh one will do it at present. Okay, seventh one. Distance of a star from the Earth is 8.33 light minutes. What do you mean by this statement? Think about it. What does this statement mean? That the distance from the star from Earth is how much? Distance of the star from Earth. It is how much? 8.33 light minute. What does this statement mean? Anyone in class? What does this statement mean?
This statement means that the light will travel from sun to earth in 8.33 minutes.
Okay, note sun. Here it start. Yes, that's correct, right? So the light will take 8.33 minutes from star to reach Earth. Light will take 8.33 minutes to travel from star to Earth. Understood this one? So the light is taking 8.33 minutes from star to Earth, to travel from star to Earth. So it started from here and it took 8.33 minutes to reach Earth. Okay? Rest of the numericals, yes?
Sir, how it was discovered that the speed of light is 3 lakh kilometer per second?
Okay, that's the experiment. Okay, that I will tell you on Monday. As well, I have to go through that. Okay.
Thank you, sir.
Okay, then we can end here. That I will tell you on Monday. I have to go through that. Okay, how we have found that.
Thank you, sir.
Okay, so we stop here. Okay, on Monday we'll discuss these numericals and then we'll take the oral test. Okay, we end the meeting here. Any doubt, go through the chapter. If you have doubt, you ask me on Monday. Okay, in class you
Thank
can
you,
ask.
sir.
Thank you all.
Thank you, sir.
Thank you.
Thank you.